In this straightforward experiment, we're going to investigate Le Chatelier's principle and the effect that temperature has on the position of equilibrium. In a moment you'll see we've set up several tubes containing cobalt chloride solution, to which we have added concentrated hydrochloric acid. The acid here is a source of chloride ions. We're not bothered by the H+. They are merely spectator ions. Let's look at the equation. Firstly, note the equilibrium sign, and secondly, notice there is a positive delta H on the equation. This means that the reaction left to right takes in energy. The hydrated cobalt complex highlighted in pink, as it's on the left hand side, can be considered the starting reagent. The cobalt 2+ ion is surrounded by water molecules that have been coordinate, dative or ligand bonded to that ion. That is where the water supplies a lone pair of electrons directly into one of the outer shells of the cobalt ion. Water is zero charge, therefore the whole complex carries the same charge as the cobalt, in other words 2+. On the right hand side, the product side of the equation, you can see that the cobalt ion has had its water molecules removed and replaced or substituted by chloride ions. The original cobalt 2+ has now got 4 negatively charged chloride ions surrounding it, meaning the complex is now 2-. Let's see what happens if we change the temperature. We have 3 different temperatures. Hot water supplying the heat, room temperature water as the contrast, and some ice cold water, the cooler part, the lower temperature. With time you'll notice there's a color change. Hydrated cobalt 2+ ions are pink, while the cobalt surrounded by 4 chloride ligands is blue. The reason that at room temperature the solution appears purple is there a mixture of both complexes present. Not necessarily 50-50. Red plus blue equals purple. Let's switch over the tubes, as this is an equilibrium, and see if you get what you would expect. Reaction left to right is endothermic, so if you deliberately give it heat by putting the reaction in hot water, it will use that energy up and drive the reaction right to left. It will change the position of equilibrium. Have a second look at the equations.